about the methods that were used in the different studies that were included in the assignment. So I think I will take 15 to 20 minutes to explain a bit more, and then you have time after that to continue working on the assignments. And I'm here, Nea is here as well, to answer any questions you may have. And if you like, I think... Oh, want ik hoor mezelf wel heel hard, maar...
Onze weblectures doet de microfoon niet, maar ik denk het inderdaad als we de microfoon...
We hadden hem net nog niet aanstaan.
Ik heb hem nu net aanstaan.
Ja.
Dat zal het zijn.
Oké, dankjewel. I think it's working, right? The microphone? Yeah. Maybe because you weren't using one, that they thought something is wrong. Well, I don't know.
Yeah, they think there's something, but...
Well, so I think it might also be good to discuss, for example, your answers together. So, first I will explain something, then you can work on it, and then I think at 4:30 we can go over the answers together and exchange your thoughts about the assignment. But first, I put also down I wrote down here the learning goals of this week actually, and you see that there's a learning goal on recognizing and using the major approaches to quantify insulin action in humans. And that's actually what the assignment was about, to get a bit more familiar with different ways of quantifying insulin action and insulin resistance as well in humans. Another thing that's important to mention is that we ask you to hand in the assignments before tomorrow 5 o'clock. So don't forget to do that as well. So I also shared this paper with you, or actually it's a book chapter in which they describe different ways of assessing insulin sensitivity and insulin resistance. There are some very complex methods to do this, also described in the paper, and we will use a few of them during the assignment. But I put down here also a comparison going from very easy or quick methods to measure insulin to more complex methods, such as the clamp method we also discussed in the lecture on Monday. And in between are things like the OMA-IR, which is a calculation you can use to quantify insulin action, and the oral glucose tolerance test. That was also discussed in the lecture on Monday. And just different ways to assess how well our bodies are able to handle the insulin that we produce. And in the assignment we used different forms of these methods. So what they also explained in this book chapter is that there are different ways. So we have direct measures, we have indirect measures, and we have approximations or surrogate measures to quantify insulin action. And the aim of all of them is actually to find out how sensitive our body is to the hormone insulin, which is not only handy in research or in trials, for example, but also if you want to know if people are healthy, you can also use these methods to say something about their health status. There are different direct measures of insulin sensitivity. There is also a part in the paper about the insulin suppression test, but you don't have to know this. I would like you to know what the euglycemic hyperinsulinemic clamp, what kind of measure that is, what kind of method. As it is actually the golden standard or the reference standard to quantify insulin action and also the insulin sensitivity of our bodies. But it's a very complex method, yes.
Can you explain the clamp?
Yes, so that's what I'm going to do right now, because it's a very complex method, and I think also in the chapter, it was explained but not really clear. To perform such a clamp method, you need people to be fasted. So what we do is when we invite people to our research facility and we want to perform this clamp method to measure their insulin sensitivity, we ask people to fast for a night, because then their glucose and insulin levels are very low in the morning. And then we infuse both glucose and insulin And in the name of the method, you see hyperinsulinemic, which means very high levels of insulin. So we infuse very high levels of insulin to a person. And then we wait until there's a euglycemic steady state. And euglycemic means that glucose levels stay even. So we wait until the glucose levels do not go up and down anymore, but they just stay stable. And this is actually what we call clamping. So we somehow clamp the glucose levels to a certain value. This process takes several hours, so it's a very labor-intensive method. You also need very high levels of insulin to infuse. You need people to stay rested for a long period of time. So it's not something we do when we have a study running with 100 participants. It's really something we use for, well, maybe 10 or max 20 people in a study. What you get out of the clamp method is the glucose infusion rate, and then you can calculate the insulin sensitivity index. And to tell you more about that, how you can actually do it, I think it's good that we go over the method, well, step by step. So what I said, we asked people to come to a research facility in a fasted state, and they should lay down in a bed because we don't want their bodies actually to use a lot of glucose during the test. So they are just, well, the purpose is that they just stay rested during this clamp. And then we infuse very high levels of insulin. And these very high levels make sure that it kind of overrules the body's own insulin production, so that you do not rely on the function of the pancreas anymore. So for example, if people are not able to produce sufficient levels of insulin, and that's why their glucose levels stay very high, you rule out this effect by just infusing very high levels of insulin in their bodies. So it overrules the internal insulin secretion. And this means you can imagine if you supply very high levels of insulin, that glucose levels drop very fast. And as you also may know, is that when you have very low blood sugar levels, that's not, well, something you feel very happy about. So to prevent severe hypoglycemia, we also infuse levels of glucose. And this makes sure that there is still glucose circulating in the body of the person. And as I said, the aim is then to reach this steady state euglycemia and to clamp the glucose levels. But it's the question actually how much glucose we should infuse, because if we infuse very high levels of insulin and then we're also infusing glucose at the same time, the glucose stays of course in your circulation, but it's also stored in your organs, because that's what we actually want, is that the cells in the body take up the glucose in response to the insulin that is supplied. And what we want to know is how much glucose should be infused to reach this steady state. And this actually depends on how much glucose is disposed. What I mean with disposed here is how much glucose is stored in your organs. And this means that if you supply glucose to this person who is lying down here, and his body is perfectly able to react to the insulin that is supplied, that means that actually most of the glucose that we supply as well will be stored somewhere in the body, for example in your liver or in your muscles. But if someone is insulin resistant, so these cells are not able to store all the glucose, you may imagine that the level of glucose in the circulation stays high as well. And this is actually what we are interested in, because the level of glucose that is disposed, so the level of glucose that is stored in the cells, is referred to as the M value. And the M value we also came across in the lecture on Monday, because it says something about the insulin sensitivity. So actually we performed this whole clamp method to know how much insulin or how much glucose we should infuse, and how much glucose is then also stored in someone's cells. And as I said, this depends on how much the level of glucose that is supplied, so the level of glucose that we need to give to the person to reach the steady state depends on how much glucose is stored in your body cells. And if you need to, if your body is able to store a lot of glucose, so it's able to respond to insulin very well. Then you have a good response to insulin, and you need high levels of glucose to be infused. But if your body is insulin resistant, this means that the cells are not able to respond to the level of insulin that is supplied, and you need you need not so much glucose because it's just staying in the circulation and will not be taken up by any cells in your body. So in the assignment we also asked you about the M value and the glucose infusion rate, and what's important here to know is that during this clamp method the level of glucose that is infused is similar to the level of glucose that is disposed in the body, and therefore it's also similar to the M value. So if you actually want to know the M value of someone, so you want to know how well the body is able to store glucose in the cells, you actually need to perform this clamp method, because only then you can know the glucose infusion rate, which is equal to the M value. Does this make sense? Feel free to ask any questions if you have. Yes?
There was also a sensitivity index, and then you have to calculate with lipids, or?
No.
The delta I,
Yeah.
the difference between fasted, that was a bit more complicated.
Yeah, so I think it's on the next slide. Because if you know the glucose disposal rate, you can also calculate the sensitivity or the insulin sensitivity index. But for this you need a bit more information. You also need the difference indeed between the level of insulin when people came over fasted and the level of insulin, like how much insulin is circulating in someone's body when they reach this steady state. And by this, if you know the difference between the two, you can calculate the insulin sensitivity index. So besides the M value, you also need the level of glucose and the level of insulin that is circulating in someone's body during this clamp method. And then you can calculate the insulin sensitivity index. So you don't need anything with the lipids here. I think in the assignment we asked you to also calculate something with the amount of lipids that were in muscle cells, and to compare this with how insulin sensitivity someone is, because we know that if there's more lipid storage in muscle cells, for example, that the muscle is less able to respond to insulin.
With a very weak correlation.
Yeah, so we will also go over that later, I think, because it's also good to to discuss your answers there. But for this insulin sensitivity index, you don't need any data on the liver or the muscle fat content. So to summarize, this clamp method is actually the reference standard to calculate the M value or the insulin sensitivity, but it's a very complicated and labor-intensive method, and it takes a long time before people reach this steady state. So it can take up to 4 hours, for example, before this the steady state is reached. And you can imagine that you need to infuse very high levels of insulin for a long period of time, which is of course not a very healthy situation. You don't want to do that every day, for example. And therefore it's only feasible in small-scale studies. Besides this direct measure, there are also indirect measures to say something about the insulin action in human bodies. And for example, I think in the book chapter they also talk about the FSI-VGTT method, which sounds very complicated, but it's actually just measuring the level of glucose tolerance at different points in time. So it's a frequently sampled glucose tolerance test. You measure the level of glucose in someone's blood at multiple times. For example, after an oral glucose tolerance test, so you will know not only what people's glucose level is when they're fasted or after 2 hours of this test, but you measure it at multiple times, so you can really see, like it's depicted here in the picture, the levels of glucose going up and then slowly going down again, because you measure it multiple times. There are also tracer studies. What they do here is that they label glucose that people consume, and so you can clearly see a difference in someone's body of the type of glucose that is consumed, for example, or for example in this oral glucose tolerance test, or the glucose that is produced by your liver, for example. And this says something about how well your body is able to take energy from any glycogen that is stored in your body. Then we have the surrogate measures, which are, well, as I said here, approximations. And these are the formulas that I think the first two we also discussed in the lecture on Monday. So, for example, the HOMA-IR, which takes both the fasting glucose and fasting insulin levels into account. And this is something you can do this very quickly. You just measure fasting glucose and fasting insulin at one point in time, and then you use this formula to calculate the HOMA index. And the same holds actually for the quickie, which is just a different formula to use to say something about the insulin sensitivity. And also here you use fasting insulin and fasting glucose levels. You can imagine that, well, asking people to come to your research facility and, just taking a blood sample in a fasted state is way easier than performing this whole clamp method, which takes several hours and, needs the people to lay down for a bit in bed. If you ask people to perform an oral glucose tolerance test, so you know how much glucose people consumed, you can also calculate other indexes, such as the Matsuda index or the gut index. And this is also formulas that use, for example, fasting glucose levels and fasting insulin levels, but also other, like the different time points that you measure glucose after consumption of the known amount of glucose. And the same holds for the gut index. These are just formulas that are made to, compare or to say something about the insulin sensitivity without having to perform this complicated clamp measure. So there were just people that wanted to know, if we measure fasting glucose and measure fasting insulin, how can we say something about the insulin sensitivity? And then they came to this formula of HOMA, for example. So in the assignment, I think I asked you to calculate a bit with, for example, the HOMA or the insulin sensitivity index. And we gave you data from existing studies that were actually performed a couple of years ago, such as the SLIM study, the ROSI, and the belly fat study. And I don't know if you already had some time to work on the assignments, but I think it's good if you maybe finalize the assignment or discuss a bit with your group, perhaps, what kind to compare your answers, and then shall we discuss everything in half an hour? So we gave you data from different studies, and we split them into 3 exercises on performing calculations with the 3. The data from the 3 studies as well. Just to give you a bit of background, the first one is the SLIM study, which was actually a 3-year lifestyle intervention focused on improving glucose metabolism in people who are at high risk of developing type 2 diabetes. And here you see some, I just put on the picture with some, the main results of the study. But you also calculate, of course, a bit yourself. And we asked you to calculate the average values for the different parameters that were given, such as the fasting insulin and glucose levels, and also the HOMA-IR values. I'm not sure, maybe you want to check your answers. But we also asked you to give a bit of an impression on the impact of the intervention on insulin sensitivity. I'm not sure if anyone wants to share something about that. So it's the answer on question 2. Yes?
The sensitivity improved slightly. The HOMA-IR of the intervention group decreased more than the control group.
Yeah, so you looked at this column, I think, to compare the HOMA-IR before and after the intervention for the the control and the intervention group. Does everyone agree with the answer that was given? Did you all hear it, or? Yeah, so what he said was that in the intervention group, the HOMA-IR decreased from 3.75 to 3.03, whereas in the control group, the HOMA-IR increased. And we know that a higher HOMA-IR indicates insulin resistance, so actually the intervention group improved their insulin sensitivity during the intervention. And just for you, the formula to calculate the HOMA-IR is this. I will also upload the slides after this lecture on Brightspace, so you can check also for yourself. Then we asked you about any other markers to give insight into type 2 diabetes risk. Any suggestions on this this question?
I thought about the oral glucose test, that you can see how quickly the body responds to.
Yeah, so the oral glucose tolerance test would indeed is another thing they could have done to measure the glucose levels. I think because they here already have different time points in which they measured glucose, they used this kind of test to indicate, of course. But I think what you say correctly is that they could also measure more frequently, for example. In the Netherlands, we diagnose people only based on fasting plasma glucose levels. So for this, you would preferably look into this column, the glucose levels that were measured at fasting or at the baseline of the study. But you can also think of things like HbA1c to indicate the level of glucose that was in someone's body for the last 2 or 3 months. We also discussed this clamp method, of course. We could also have decided to perform this method, but I think it's because they had a lot of participants in this study, that wouldn't be really feasible to use. We just asked the question for you to have some indication on what kind of different measures you can use to say something about the risk of type 2 diabetes. The second study we shared with you was about a specific drug. And in this study, they actually did use the clamp method. So as you can see, there are indeed only 20 people that participated in this trial, because as I said, it's very labor intensive to perform the clamp in a larger population. So we asked you about this GIR, and I'm wondering what your thoughts are about this question. So what is actually the GIR? What did you write down here? Anyone who wants to share his or her answer? Or any questions about the assignment? So I can also give it away. I think we just discussed also about the clamp method, and that the GIR is the glucose infusion rate. And then I asked, what's the relation then with the glucose disposal rate? But during the clamp method, it's actually the same. So I think it's important to remember that when you perform this clamp method, you actually want the M value to be calculated. And this is the glucose disposal rate. But during the clamp, it's the same as the glucose infusion rate. So by measuring how much glucose is infused, you also know the M value. Well, the second question was about limitations of the clamp. I also discussed it with some of you already, that it's very complex method. You can only perform it in small groups. I also mentioned it's very expensive. You need to supply very high levels of insulin. Those are all limitations you can think of. And then we asked you to calculate the M value. Well, I think with the knowledge that the GIR is the same as the M value in this clamp, you could calculate the average before and after treatment. So just to compare your answers, I show my calculation here. And then we also asked you what you think about this difference. So I see that after treatment, the GIR is increased or higher than before the treatment. And what does this tell us about the insulin sensitivity? Yes, what do you think?
Is more sensitive, more insulin sensitive. On average, the patients are better able to store glucose.
Yes, because the glucose infusion rate is higher, right? So we needed to supply more glucose after the treatment because apparently more glucose was also stored in the cells. Yeah, so the insulin sensitivity actually improved with this treatment. Then we asked you about the insulin sensitivity index. Well, I think I also showed the formula in the beginning of this afternoon, which looks like this. And in addition to the M value, you also need information on the steady state glucose concentration. That's actually at what level the glucose levels are clamped for an individual person. And you also need information about the difference between the fasting and the steady state insulin concentrations. So in addition to the M value or the glucose infusion rate, you need measures on glucose and insulin at the steady state for the person to calculate the sensitivity index. Then there was a part about the fiber, like the muscle fiber and the lipid content in the different types of muscle. And again, we asked you to calculate the average values. And if you look at the values, you also see, for example, that these the content of fat decreased after treatment, or at least the values go down. And if you have to relate this to insulin sensitivity, can someone share what you think about this? How does the content of the fat in a muscle relate to insulin sensitivity?
Sensitivity increases, the amount of fat decreases.
Yeah. So for these averages, if we see the fat content decreases, I would say the insulin sensitivity increases then. Yeah. So this also is in line with the previous calculations that indeed the insulin sensitivity was increased after the treatment. Although the differences are not very big, but still we see some slight improvement, yes. So I think I already answered what's the effect of the treatment. Well, we saw a change in insulin sensitivity here.
Iris, what is
Yeah.
what is the unit of the fat?
It's percentage.
Okay.
Yeah. Yeah. So how much? Yeah. How much?
How much of your muscle tissue is
Fat.
What percentage of your
Yeah.
muscle tissue is fat?
Yeah. You can, for example, measure that by taking a biopsy from the muscle. Yeah. And then the last study we shared with you was about the belly fat study, which is also the study I shared with you on the lecture of Tuesday about the high and low quality weight loss diets, in which they measured a lot of things to see what the effects were on after the two different diets. So we asked you to complete the table, so calculating averages and also the ranges of the values here. Well, I think you now know how to calculate the HOMA-IR. So here you see the average numbers and also the ranges of values, like the minimum and maximum value that were in the data set. Can anyone tell a bit about, well, I think for age we don't really need an interpretation, but for fasting insulin levels, if we look in the average value, 10.8, what do you think about this value? Is this something that's high or low? Did you find any cutoff values for this? Yes.
I think it's high. I believe that it's above 11, then it's diabetes.
Mm-hmm.
Fasting, if they're fasting in, oh no, that's glucose, sorry.
Yeah, so it's here. I agree with Nea that there are no units in here, but it's indeed the fasting insulin levels. We do not really have a cutoff value to diagnose someone with diabetes if we're only looking at fasting insulin. But well, if you start looking in the literature, you will find that we usually take a level of 25 as a cutoff value to say if the levels are very high, that there's something going wrong with your insulin metabolism. So you preferably want this value to be below 25. So on average, I think this group does very well, but we see that there are also some people who are above this value. But for the glucose, indeed, you refer to the 11.1. I think here it's good to remember that it's fasting glucose. So for fasting glucose levels, we have, yes, 7 is the cutoff we compare this value to. Or even 6.1 if we're talking about pre-diabetes. So for this, I would say the group, well, there's no one who actually classifies as having diabetes in this group. And then the HOMA-IR, well, I think we already discussed a bit about reference values for the HOMA-IR level. So you can see here that it's, well, slightly increased. So there is some insulin resistance in this group. Or, sorry, no, the level is a bit higher than 2. But you can also see here that the range is very large. So there are people who with a very low HOMA level, HOMA-IR, and a very, well, quite high HOMA as well. The hepatic lipid content is also a percentage of how much fat is present in the liver. And also here you see that some people only have 0.14%, whereas others have almost a third of their liver containing any fat. So there's quite a big range for the lipid content here. Yeah, for lipid content, there's also not really a cutoff value we refer to. In most studies, we use a value of 5% to classify people as healthy. So the ones who have 30% here are really, really have a fatty liver. And I would also say on average that this group has some, liver fatness that is above the threshold to be classified as healthy. So there is, there is some fatty liver in this population. Then we asked you also to correlate the hepatic lipid content with glucose, insulin, and HOMA-IR levels. And some of you already said, well, there's not really a clear correlation between all these different measures. Especially for glucose, you see, well, quite a flat line and just a cloud of values. Also, the R squared is quite low. But for insulin and HOMA-IR, the associations are a bit more clear. I think here it's good to remember that these are all non-direct ways of assessing insulin sensitivity. So I would expect that when we perform this clamp method, for example, and we measure the lipid content in the liver, that the correlation would be much stronger than we see right now. Just because these are only fasted levels of glucose and insulin. I think that's one of the explanations why the correlations are not that strong. And then the last question we had was actually, what is the consequence of lipid storage in the liver in respect to insulin sensitivity? I think this is similar to the question on the lipid content in your muscle, but also for for the liver, it's actually the same process as is for the muscle cells, that the more lipid storage you have in your liver, the less insulin sensitivity your liver can be. Any questions on the assignment or on anything else? No? Is it all clear? Well, great. Then I think the only thing that I want to share with you is that you, well, please don't forget to hand in the assignment also on Brightspace before Friday afternoon. And I will also share as I said, the slides with the answers after you all uploaded your assignment, so you can also for the exam go over the assignments yourself and check it then. Do you have anything to share, to add?